When there are three terms and we're trying to factor, we should always say, boy, I hope it's a perfect square trinomial. Perfect square trinomials are going to be very easy for us to factor. So anytime you see three terms, say, boy, I hope it's a perfect square trinomial. Let's remember our steps for factoring. First, we take out a greatest common factor if we can. Next, we count the terms. When there are four, we group. We saw earlier if there are two, difference of squares, but now with three terms, we hope it's a perfect square trinomial. If it is, it'll factor as some binomial being squared. Well, to be a perfect square trinomial, we have to have three terms with nothing common. In addition, there must be a square on both ends, a positive at the back, and an even middle term. All of these things have to be true for it to be a perfect square trinomial. For our first example, we've got nothing common. There are three terms. We have a square on the front, a square on the back, a positive at the back, and an even middle term. So this appears to be a perfect square trinomial. If it's a perfect square trinomial, then we can factor it as a binomial being squared. To get the terms of the binomial, let's do the square root of the first term. The square root of x squared is x. Let's take the sign that is in the middle of the problem. Here it was a plus, so we'll put a plus. And then let's take the square root of the last term. The square root of 9 is 3. Now, as long as there's no coefficient with this, there's a trick that can make this maybe a little bit easier for us. For it to be a perfect square trinomial, the square root of the back also matches half of the middle term. What is half of 6? Half of 6 is 3. Square root of 9 is 3. So for most people, doing half of 6 to get this 3 is easier than doing square root of 9. Those things must match if it's a perfect square trinomial when there's no coefficient involved. Let's look at another. Here, there is a square on the front. There is a square on the back. A positive at the back with an even middle term. Let's take the square root of the first one, then the sign that's in the middle, and half of this middle term or square root of the back. Either way, half of 4 is 2, square root of 4 is 2. Either way, we get to 2. This binomial needs to be squared for us to end up with something that is equivalent to the perfect square trinomial that we started with. Remember, we should be able to multiply this back out and get back where we came from, so that square is necessary for us to be able to do it. Sometimes things masquerade as perfect square trinomials when they're not really perfect square trinomials. Here I've got a square on the front, a square on the back, a positive at the back, and an even in the middle, so it appears to be a perfect square trinomial. But when you start factoring it, notice that half of 2 is 1, the square root of 4 is 2. Those things don't match, so this is not a perfect square trinomial, and it's actually going to be prime. Remember, we have to be very careful before we call something prime to be sure that there's no factoring that can be done to it. It's going to be rare for us to see things that are prime. For a perfect square trinomial, there should be nothing common. There should be three terms with a square on each end, a positive at the back, and an even in the middle. If we have that, it factors as a binomial being squared by taking the square root of the first one, the sign that is in the middle, half of the middle term, or square root of the back.